Today we will be looking at scientific notation. Please copy the standard benchmark indicator on a clean page in your math notebook. The student will investigate and describe the concept of scientific notation. Scientific notation. Scientific notation is an easier way to write very large and very small numbers. A number in scientific notation is written as the product of a number between 1 and 10 and a power of 10. You write the power of 10 using exponents, with 10 as the base and the number of times 10 is a factor as the exponent. Example 1. Write 4 and 2/10 times 10 to the 7th in standard form. The power of 10 tells you how many places to move the decimal point. Move the decimal point to the right 7 places. So if you look over there at the right, the decimal goes from in front of the 2, moves behind it, so that's 1 place. Then it has to move 6 more places. There aren't any numbers there, so to fill in the spaces and to hold the place value, we add zeros. So it went past the 2, so that's 1 place, and then they had to have 6 zeros to add in to make sure that the decimal ends up in the right spot, which is at the end of the number, so you don't need to write it down at that point. But the exponent does not tell you how many zeros to add. Tells you how many places to move the decimal. So 4 and 2/10 times 10 to the 7th becomes 42 million. Try it. Write 6 and 12/100 times 10 to the 9th in standard form. How many places to the right will the decimal move? To figure that out, we look at the exponent, which is a 9. So we're going to be moving our decimal 9 places. So now we're going to write the 6 and 12/100 off to the right there so we have space to actually move the decimal 9 places. Okay, as you can see, we've moved the decimal 2 places so far, so it goes past the 2, and then we have 7 more places, but there isn't anything there. So we're going to put zeros in as placeholders. So now we're going to rewrite the number over on the line and put the commas in where appropriate. So we end up with 6,120,000,000. For C, we have 5 and 6/10 times 10 to the 7th. So the decimal needs to move 7 places. It's going to go once past the 6 and then 6 more places. So we went 1 place past the 6, 6 more places, which we filled in with zeros. So we end up with 56 million. For D, we have 182/100 times 10 to the 6th. So we're going to move the decimal place 6 places to the right. Then we fill in those empty 4 places with zeros, and we get 1,820,000. For example 2, we're now going to take large numbers and put them in scientific notation. So we're going to write 7,089,000 in scientific notation. We're going to write that number as a product of 2 numbers. The first factor is the decimal number with 1 digit before the decimal. To write this number, move the decimal point to the left 6 places. So every whole number has an invisible decimal floating at the end of it. So basically, we're bringing that decimal from the very end of the number all the way up to right behind the first digit, which in this case is the 7. So our decimal number becomes 7.089. So you have to continue writing it out until all that's left behind the digit is zeros. Then it's times 10 to the 6th. It's always going to be a multiplication. It's always going to be a base 10. And the reason the exponent is 6 is because the decimal came from the end of the number and moved 6 places to the left. So for the try it, we're going to write 908,000 in scientific notation. So for letter E, how many places to the left will the decimal point move? So if we imagine the decimal at the end of the number, we're going to move it 5 places in, so it ends up right behind the 9. So the first factor is going to become our decimal number between 1 and 10. So in this case, it's going to be 9.08, so 9 8/100ths. The second factor is always going to be a base 10 to an exponent. In this case, our exponent is going to be 5 because that's how many places the decimal moved. So now we're going to write it all together in scientific notation. So it becomes 9 8/100ths times 10 to the 5th. For I through L, we're going to write each number in scientific notation. So for I, we have 423 million. We're going to bring our invisible decimal from the end of the number all the way up to between the 4 and the 2, a total of 8 places. So our first factor becomes 4 23/100ths times a base of 10, and the exponent is going to be an 8 because we had to move the decimal 8 places to the left. For J, we have 50,600,000. So we're going to take the invisible decimal and move it 7 places all the way up to right behind the 5. So our first factor becomes 5 6/100ths. We have to have that 0 in there because there's no way to know it's there by the factor times 10 to whatever. So it's got to be part of that decimal point. So you can't start dropping off the number until it's just zeros at the end. So it becomes 5 6/100ths times 10 to the 7th, because 7 is how many places we move the decimal. For K, we have 120,000. So we're going to move the decimal from the end all the way up between the 1 and the 2, a total of 5 places. So our first factor becomes 1 2/10ths. We're going to multiply it times 10 as the base, and the exponent is 5 in this case because that's how many places we move the decimal. Finally, for L, we have 90,060,000,000. So we're going to move the decimal from the very end of the number all the way up to right behind the 9, a total of 10 places. So we end up with 9 6/1000ths times, we're going to have a base of 10, and the exponent in this case is also going to be 10, because that's how many places we had to move the decimal. So the important thing to remember about scientific notation is that that exponent tells you how many places you're moving the decimal, not how many zeros you're adding. So make sure you're counting your places very carefully. And please glue this worksheet into your math notebook.